First, we want a way of demonstrating that a function has a root in a given interval. This means that somewhere in this interval lies the x value that makes the function equal to 0, even if we don't know exactly where it is. On a graph, that means somewhere in this interval, the curve crosses the x-axis. The simplest way to verify a root lies in the region is if the value of the function switches between positive and negative between the two endpoints. A switch in sign means that the 0 value must have been crossed. For example, we can show the function x cubed minus 1 has a root somewhere between 0.5 and 1.5. Since at x is equal to 0.5, the value of the function is negative 7/8, and at x is equal to 1.5, it's 19/8. This switch in signs indicates the true root is somewhere in this interval. Iterative methods can be used to solve equations. I want you to imagine that we have an equation that we can write as x is equal to some function of x. On a graph, the solutions to this equation are the intersections between the line y is equal to x and y is equal to f of x, which we imagine to look like this. An iterative method says that if we start with some guess for the solution of x, a next guess can be obtained by plugging that initial guess into the function f. We repeat the process with this new guess and hope we get closer to the true solution. On a graph, it looks like this. We take some initial guess x and see what it outputs from the function. We then want that y value to be our next guess, so we go along until we hit the line y is equal to x and go down. This new guess is inputted into the function and we repeat the process over and over. Doing this can result in a few outcomes, not just success. Often, the guesses will converge towards the true answer. Equally, with a different initial guess, our successive guesses could diverge away from the true answer and off to infinity,